Thank you, everyone. We're going to start right on time tonight. So first of all, good evening and welcome to the 2024 Technophilosophy September Soiree. For those who don't know me, my name is Karina Vold and I'm an assistant professor at the Institute for the History and Philosophy of Science and Technology here at the University of Toronto. I'm also a research lead at the Schwartz Reisman Institute for Technology and Society here at UT. I want to thank you all for making the time to join us tonight for what I'm sure is going to be a fascinating discussion about the challenge of building safe and reliable artificial intelligence. I want to start by introducing our panelists and say a little bit more about tonight's event in just a moment. But first, let me start by acknowledging the land on which the University of Toronto operates. So Toronto is a special place, and for thousands of years, Toronto has been the traditional land of the Huron, Wendat, the Seneca, and most recently the Mississaugas of the Credit. These and other Indigenous people across Turtle Island developed complex and effective governance systems based on respect for all life and the intelligence of the natural world. Today, this land is still home to many Indigenous people working to reclaim their rights to self-determination, and we're grateful to have the opportunity to live and to work on this land. And now for a little bit of housekeeping, let me say a few words about the incredible group of people and organizations it took to put this event together. First, my thanks to the staff and leadership at the Schwartz Reisman Institute for supporting this event from the start and including its inaugural iteration back in 2022 and tonight for the second time 2 years later. So as I said, Toronto is a very special place, and as most of you know, the seminal work of Geoffrey Hinton and his students established this place as the birthplace of modern artificial intelligence. And today we're fortunate to have places like the Schwartz Reisman Institute and the Vector Institute here working not only on advancing artificial intelligence in Canada, both in research and in application, but also on doing so safely, responsibly, and with human well-being in mind. And I want to extend my gratitude to the Vector Institute and again to Schwartz Reisman Institutes for being our co-hosts for this evening, alongside our friends and partners at the University of Toronto's Centre for Ethics, my home department, the Institute for the History and Philosophy of Science and Technology, and Victoria College, where we're situated for tonight. Now let me tell you a little bit about what to expect for tonight. So first, I prepared some questions for our panelists, and we'll engage in an on-stage discussion for the first portion of the evening. After that, we're going to open it up to you, to the audience, to ask questions to the panel. And just as a heads up, if you're located in the floor section of the theater, you can raise your hand and wait until a microphone's brought to you. And for anyone located in the theater who maybe doesn't want to use their own voice, raise their hand, or for anyone located up in the balcony, we're going to be using a digital platform called Slido, where you can type in your question. So I'll provide more instructions on how to do this once we get to the Q&A period. Now, I want to note that this event is being recorded. There were quite a few folks who wanted to attend but weren't able to, and so we're going to be posting this online for public viewing at a later date. With all that covered, okay, I want to now just introduce our esteemed panelists for tonight. So on the far right sits Roger Grosse. Roger is Schwartz Reisman Chair in Technology and Society and an assistant professor in the University of Toronto's Department of Computer Science. He's also a founding member of the Vector Institute and a member of the technical staff on the alignment science team at Anthropic. Roger's work on improving our understanding of neural net training dynamics and his more recent focus on applying our understanding of deep learning to AI alignment are both critical in this moment of rapidly advancing AI. Roger holds a Sloan Fellowship, a Canada Research Chair, and a Canada CFAR AI Chair. We're also joined by Sheila McIlraith on the far left, Sheila, who is an associate director at the Schwartz Reisman Institute, as well as a professor in the Department of Computer Science here at U of T. Sheila is a world-leading researcher with over 100 scholarly publications in the area of knowledge representation, automated reasoning, and machine learning. Her work focuses on AI sequential decision-making, broadly construed, through the lens of human-compatible AI. Sheila is also a Canada CFAR AI Chair at the Vector Institute and was just this year awarded a Lifetime Achievement Award from the Canadian AI Association, a well-deserved honor for a senior leader in the field. Finally, we're joined by Sedef Kocak, who is the Director of AI Professional Development at Vector Institute, where she leads programs aimed at building workforce capacity in AI and integrating advanced technologies into work streams in industry. Sedef was named one of the top 25 women in AI in Canada by Rework and was recently appointed adjunct professor at Ontario Tech University's Trustworthy AI Lab. She has a number of large-scale, multi-industrial projects at Vector and frequently serves as facilitator, chair, and co-organizer of AI academic conferences and workshops. Thank you all to begin. Thank you all for spending the time and taking the time to help us have this conversation with this audience. I really appreciate it. All right, without further ado, let's begin. Start by just joining them all here. All right, so I wanted to start with a question for Sheila. And I might pitch this to the whole panel too, but just to get us started for the audience, I want to know, what does AI safety mean to you? What is AI safety? When we talk about that, what is the field that we're referring to? And why is it a problem? Why is it a hard problem that takes so many researchers to focus on?
So thank you, and I'd like to say thank you for inviting me to participate in this event. So AI safety actually evokes a lot of different things from different people, and I think for computer scientists, often they think about safety critical systems. That's the first thing that comes to mind, the types of systems that we build to send astronauts to the moon or to control our nuclear power plants. But AI safety is actually quite different, and a common lay definition of it is that the endeavor is the theory and practice of deploying AI systems that will not harm, in different ways, that will not harm humanity in some ways. For me personally, I guess I have a higher bar. I really think that we should be building AI systems for human flourishing. And to that end, I really think that what we aspire to in the long term is really building systems that will allow human beings to live with dignity and purposefully, and to be able to contribute valuably to society and to feel that they are recognized for their valuable contributions to society. That all sounds a lot, it's highfalutin, but when we work in the technical field, actually those aspirations translate into a number of very specific sort of technical challenges and maybe a high-level description of those there are challenges associated with specification. How do we tell those AI systems what we want them to do? Reliability. How do we ensure that our AI systems are reliable in the face of all sorts of different data and perturbations within the world? And also, how do we assess and monitor those systems to ensure that they're really doing what we want them to do? I wanted to just pause for a minute and mention one particular problem within AI safety that people probably heard a lot about, which is an important one, which is the notion of AI alignment, which is really the notion of trying to build AI systems that are aligned with human, the diversity of human values and perspectives. Just to finish though, I think I'll very quickly answer your question about why it's so hard. And it is hard. I mean, part of it is actually understanding what we want to do. What do we actually want these AI systems to do? What values do we want them to have or exhibit as they are interacting in the world? But also, I think there are problems associated with both the speed at which technology is being built and the financial incentives to actually produce a product very quickly. And what happens there then is that there's technology is really advancing quickly. There's a lot of incentive to get new products out, perhaps before they have been fully tested. And with new capabilities, it's very hard to understand just how to assess them, how to evaluate them, and how to regulate them. The other challenge, and this will be the last thing I mentioned, is data. You know, we have a lot of data. In fact, we've exhausted a lot of our data, but I still feel like we don't have all the data that we need to truly achieve what we want with AI, to really reflect the values of humanity. Because a lot of, I mean, just to give one example, a lot of what we care about as human beings goes on in our head. That dialogue or that monologue that you have with yourself, that feeling that you have when you had a baby a little while ago, those feelings that you feel towards your children or towards somebody that you feel compassion towards, those are not things that we have data for. And so if we're really going to build systems that reflect the diversity of our human values, I think we need more data than we have right now.
That's great, thank you, Sheila. That was a sort of a high-level question, so that was a great answer to a hard question, which I'm now also going to put to Sedef and Walter, actually. I wonder, like, in a sentence or two, if there's anything you wanted to add to what AI safety sort of means to you and why it's so challenging. Sedef, I wonder if I could put that to you first, and then I'll ask Walter.
Yeah, sure. Thank you so much. Again, thank you for inviting me, and then this is a great honor. And thank you all for joining us today, although we have another big debate coming up right after this one. So thank you for joining us and spending time with us. So yes, I really like what Sheila said, that we have challenges, of course, all of the systems now we are building, now we are using, like I am a user, like Sheila, Rogers are developers, and maybe some of you are developers, some of you are users, so we have different perspective of what the safety means for the user's perspective, for the developer perspective, for the in different maybe industries and health or like education and so on and so forth. So we need to think about how those are in common, like what does it mean in safety for each of those users, developer, or in the different industries and so on. So I think that one challenge also, this kind of systems are dual systems. So it could be give a positive outcome that we wanted to, and it could also go bad and then harm people or societies or in many different ways. So I think this is the challenge, that those systems are like a dual systems and doesn't have much of a physical interactions. But again, we need to think about this kind of challenges. And then of course, going back to what Sheila was saying, that data is really important, that we need to think about how we wanted to create those data, what kind of data, what are the what kind of challenges within the data. We're going to talk about later probably like a bias in different ways. So those are the two challenges I've seen, and then the safety means that for who, for how long, of course, how are we going to integrate different values of humans, democratic values, rule of law, and all these needs to be incorporated when we think about it. So I'll stop there and then pass it to Roger.
Thank you.
Yes, I think these have all been great insights. What I would add to it is that when we think about the safety of AI systems, you have to think about the rate at which they're progressing. Because traditionally, for almost every AI technology that's been developed, it's developed for some purpose, and there might be harms that are associated with that purpose, right? We build systems to analyze lots of data, maybe that leads to privacy invasions, military AI creates certain risks. And what's really different about large language models is that we have these systems with very general capabilities. They have knowledge about areas that weren't intentionally programmed into them. They've just learned it from reading lots of generic text. And so this kind of raises the possibility that the models will be able to assist humans in various purposes like cyber attacks and building weapons and things like that. Basically, just a chatbot acting like a source of expertise that most bad actors normally don't have access to. And as the systems continue to improve, they might not be so much chatbots that you ask for information, but would actually have some capability of acting agentically in the world. And so once the AIs have the ability to autonomously carry out plans, then we have to worry about the motivational structure. Could there be some reason they might be incentivized or otherwise have a tendency to want to carry out a complex, harmful plan? And so when we think about, is the system safe, we have to think about not just what are the systems we have today and what are the capabilities, but what are we likely to have in 5 years from now, right? At the rate that things are progressing, we could actually have very powerful systems that could be hard to control.
Thank you very much, Roger. I have another question for you now. So I know that you've made some major contributions to the scholarly literature and also some of the sort of technical solutions to AI safety, especially thinking through different levels of AI safety. And I wonder if, somewhat briefly, you can suggest sort of how these level systems work, what the strategy would be for measuring or quantifying different sort of thresholds of AI safety.
Yeah, very great question. So I made this general argument that you have to think about the level of capabilities of AI systems when reasoning about our safety precautions. And a great way of formalizing this is Anthropic's notion of AI safety levels. This is something that I was involved in formulating a couple of years back. Basically tries to categorize the level of risk posed by an AI system into different AI safety levels, which are inspired by biosafety levels. So AI safety level 1, ASL1, would be a system that just completely obviously doesn't pose any serious risk, like AlphaGo. ASL2 is what we're currently at, which is systems that we believe are not directly catastrophic risks. They don't have catastrophic capabilities, but they have enough warning signs that we should be monitoring them carefully. We should be testing them carefully to test for capabilities we might miss. And then ASL3 would be the first level that poses a serious human misuse risk. So the UK AI Safety Institute, for instance, is testing the frontier models for whether they can accelerate humans in building various kinds of weapons. They have government experts who know what are the steps of the process that can limit what bad people can do. They will test humans in carrying out tasks, either with or without the help of an AI with guardrails removed. If the group of AI can do the task significantly faster, then that would be the criteria for the model being ASL3. And then ASL4 hasn't yet been defined, but it's likely that the definition would include something like being able to act autonomously. So to carry out an entire plan from start to finish, a wonderful example of this is autonomous replication. So can the model make copies of its own weights onto a cloud provider and run itself, and make enough money somehow, either through mechanical turk or through phishing or something like that, to be able to keep those copies running. If you can do that, then it effectively becomes fully independent of human oversight. And then there are a lot more things it can do once it has that capability. And so that's probably not the end of it, right? There will probably be more levels beyond that that require even higher degrees of precautions. And so essentially, when we're trying to ensure the safety of one of these systems, we have to calibrate the precautions to the level of risk posed by the system. So at ASL2, the precautions are largely about evaluating the capabilities so that we know if we cross into the next level. At ASL3, it would be largely about preventing the technologies from falling into the hands of human bad actors. So ensure that the models can't be jailbroken, that there isn't some magic prompt you can use that makes it, that essentially gets it not to refuse to do whatever you want to do, give napalm instructions, whatever. It might be important to keep the model weights secure. As it currently stands, if the human attackers can access the model weights, it's pretty easy for them to train away whatever the guardrails have they put it. They can train away fuses and things like that. It might be possible to find some technical solution to that and actually remove the dangerous knowledge from the model. But as it stands, security would be a pretty core requirement for the ASL3 level capability. And as the capabilities progress beyond that, then we'll have to be able to really understand the motivational structures of the AI systems. So be able to guarantee high reliability, that they won't try to carry out a nefarious plan on their own, and also rule out possibilities like maybe they know their AI is being evaluated and are deceiving their daters about their capabilities and motivations, so that they'll eventually be more likely to be deployed and accomplish their ultimate goals. So as the systems get more and more powerful, the requirements for ensuring the safety get increasingly stringent.
Thank you very much, Roger. That's a lot to summarize, so I appreciate that. One term that you used a couple times is frontier models, and I'm wondering if the audience is comfortable with that. So I'm guessing everyone's heard of a large language model. Can I see a show of hands of how many people have interacted with one of them? Okay, I should ask, is there a show of hands of anyone who hasn't interacted with a large language model? Okay, so basically everybody. What would you say between like the difference between a frontier model and a large language model? How do those two terms interact?
I think frontier model is not a technical term. I'm just using that to refer to whatever is the most capable set of models of the day. And it's a little bit surprising that the capabilities of these models seem to be reasonably well described by scalar value. There's a sense in which GPT-4 is just smarter than GPT-3. It's really hard to come up with pretty much anything that GPT-3 can do better than GPT-4. I think there may be some creative writing tasks that that GPT-3 might be better at just because of some kinds of tuning that were applied to GPT-4. But in general, as the models get larger and trained on more data, they just generally get more capable. And so there does seem to be a well-defined notion of, okay, there's this set of models that are actually on the frontier of current capabilities. But that might not be true at some point in the future. Maybe different capabilities will branch off, but it seems to be a reasonable description today.
Okay, perfect, that's helpful. Okay, so one thing I wanted to switch to, it seems like everyone's interacted with large language models. I'm assuming everybody's been seeing all these different headlines of AI in their news feeds as well. So in general, it seems like fiction and the way in which the media discusses AI is not only sort of influencing public perceptions of this technology, but also highly influencing different imaginings of what technological risks and possibilities there are. So the question I have for Sedef, if you don't mind taking this one, is what do you think of the way that AI is being presented in media, such as film and television, as well as in news headlines today?
Yeah, this is a great question, and I often ask myself when I, watch a TV or a new film come up with like related to humanoid or the computer systems overtaking, humanity and so on and so forth. And also some books such as I recently read about Clara and the Sun. So I'm not sure how many of you know about or read this book. Clara and the Sun?
Yeah.
Oh, quite a few. That's great. Yeah. So I was really amazed at how the narratives came up with. And I think that the books or written media and maybe the television devoted more attention to a different aspects of philosophical, social, or maybe even a psychological aspect of AI. So in this book, for example, Clara is an android brought to the home to help a teenager who is lonely and homeschooling and whatnot. So really this kind of narratives are important to maybe bring those into the showing that the fears of the population or a positive impact of those kind of the technologies. And then when I saw like a first humanoid Sophia, the robot, in 2018, when I was at one of the conferences in Toronto, and then like most of the people are really, really amazed at how this interaction, like how the Sophia is answering the questions of the reporters and whatnot. And then I think that the year after, the Sophia became an actual citizen of Saudi Arabia in the country. So it was really interesting to see, but I thought that I wasn't shocked because I see that now as AI is catching up the movie, the industry. So all of this, I say that, this kind of like a narratives or like a sci-fi now turning to science fictional AI. And then I think that the communications with the public and the policies, and maybe even sometimes it affects some of the not the scientific, I would say, but some of the narratives within the science or this kind of the film and the television. So the real question is how these narratives created the generating engagement and excitement without the hype. So I think we need to ask these questions ourselves, and then how this could take into account like how we show our fears, how we show our some of the societal impact of those kind of technologies. Of course, some of the films that you might see also be impacting, like showing the impact on some of our life dramas, like people are maybe more like living in a technological world and techno-sized, and then people are feeling alone, and then we are interacting with this kind of the chatbot or like friends, Android friends and stuff like that. So I think this is a lot of narratives and social implications, sociological implications on this. So I think that we often see like those two kind of like a humanoid, like a human and human kind of interactions, and then the human voices and stuff like that. And the second one is the big systems are taking over the humanity, and then they're ruling us. So those two are like extreme, and then showing that how would be it possible. But again, I've seen, for example, the Nature, for example, it is like a printing press, and the Nature since 2009, Nature has a section of science fiction. And then recently I've seen that a lot of those kind of stories related to like AI development, what will the future look like, and then I think that it gives us a little bit of course, like this is like a fear of like a future, like how we're going to be prepared and how this looks like. So I think that's my answer is there are hype, of course, like we've seen in the media, we see it in the films and whatnot, but those are, we need to, of course, educate people, so then, a good communication with the public and, the policy makers and so on. So we need to really think about how those communications will be done within the media as well as the printing press.
Thank you for that. I wonder, for Roger and Sheila as well, what do you think about, when you read headlines about AI, are you struck by, does it also feel sort of hyperbolic? Does it feel like it's feeding into some of the narratives as Sedef pointed out, where it's sort of, a lack of control over it, or sort of a hyperbolic narrative that the system is gonna, be sort of going rogue or something? Or does it feel like it's actually, media is doing a pretty good job of talking about some of the concerns that companies have?
Yeah, and actually, I maybe respond to what I think is maybe an implication question.
Yeah, sure.
That the worries about AI risk maybe come from sci-fi. And there's a long history of sci-fi portrayals of AIs taking over. But none of that really had that much influence on the concrete reasoning about AI risks. And actually, going to the theme of this event is the Technophilosophy event. And I think a lot of the early reasoning about AI risks was more of philosophy. right? Why philosophy? Well, if we're trying to reason about AI systems that don't exist yet, or you don't have any empirical information about it, you don't know, what their design will be, you don't know what capabilities they'll have, but what we can do is maybe come up with various thought experiments. What if we design an AI that has some terminal goal and all its actions that it takes are in service of that terminal goal? And that's something, it's a thought experiment, it's something that we can spell out mathematically. Before the AI has been spending decades developing formalisms that are able to ask questions like this. And so you can go through these different thought experiments, and a lot of them end up with, well, the AI develops instrumental subgoals to deceive its users and to acquire resources and all these other things that, if it became powerful enough, would be evidence with human existence. And so before the last decade, we had incredible progress in AI. I think a lot of the reasons for being concerned about the long-term existential risks really came from this careful philosophical reason. I think what distinguishes this from fiction is that fiction is also, it's largely designed to be entertaining, right? The portrayals of AIs are whatever the reader would find most engaging, not necessarily the thing that's most likely to happen. But we can also, philosophy is a form of hypothetical thinking where you're really trying to get the right answer. And so I think that is, maybe a better origin story for thinking about AI risks.
Yeah, that's really helpful. Everyone's probably heard of Asimov's three laws of robotics, I'm guessing, or many people have. This is sort of early science fiction works about programming a robot to have certain laws of like do no harm to humans, do no harm generally, and I can't remember what all they are. But anyways, the point is that as a work of fiction, the authors often, so most of the stories that go around these laws coming into conflict somehow, right? So some sort of conflict arising from them. So the idea was not like to propose this presumably as like a suggestion as a way to proceed, but as to kind of come up with like an entertaining story around how these laws would lead to some kind of like friction and therefore have like a narrative structure. Whereas I think Roger rightly points out a lot of what's going on in philosophy when we come up with a thought experiment is to not try to create something entertaining, although sometimes the thought experiments are entertaining, I think, and sometimes coming up with something entertaining enough to keep your students engaged isn't a bad thing. But it's often to sort of illustrate some kind of conceptual point that we can't rely on sort of any kind of empirical investigation to achieve, especially as when we're talking about sort of future possibilities of technology. Sheila, I wanted to see as well if you wanted to weigh in at all about sort of even just your own personal reflections on the headlines and hype around AI and how that sort of either feels like a good reflection of what's happening from the inside, or sort of a misalignment, if I will, with what's going on.
So I'll answer your question, but if I may, I'll ask you a question first, just in reaction to what you were just saying about the philosophy, and I appreciate both Sedef and Roger said. I'm curious whether now the thought experiments are being informed by the technical work, by what's actually possible. So as Roger pointed out previously, we didn't know what these systems were going to be like, but now we have a better sense of the actual pathways to realizing AI or AGI potentially. And I'm curious whether that informs your thinking now.
Yeah, I think definitely. So I think within philosophy, for those who don't know, any of the sort of class, you were a student back when I was doing my undergrad in the early 2000s, and you wanted to take a course on AI, it would, you'd maybe get one lecture, it would be on sort of Turing's test and John Searle's Chinese room response to it, and it would be in a course called something like Minds and Machines, which is actually a great course. Professor Jennifer Nagel is teaching it this year, so I highly recommend it. But since then, much has changed. Now we have entire courses in philosophy on AI alone. And it's true that for those sort of working in this somewhat niche area, or growing area, there is like a lot of more fine-grained sort of thinking and thought experiments around more specific issues around what these certain technologies can do. So, for example, most of you may have heard about the moral sort of trolley problem and whether or not the self-driving car should, hit the row of ducks that are crossing the road, or should hit the the school bus of children or whatever. They make these terrible decisions, and so now we're like, okay, hold on, like there's more nuance into what's going on when we think about like moral problems with AI. When we think about what Claude can do, which is one of the large language models that Anthropic produced, we have to think about what kind of response is Claude going to give if you ask for help. Let's say, say I have some malicious ends, and I say, look, what's the best way to commit a crime? What's the best way to shoplift or something like that? We don't want Claude to give an answer to that. We want, hopefully we would want our large language models to say something like, well, no, I actually don't want to give advice on that. But that's sort of a different type of answer we want to give than if someone were to say, look, I own a shop, and I suffer from people coming in and perpetrating shoplifting on my products or taking products from me. What can I do to prevent that? Right? So depending on what your aims are, we want this large language model to give some information about that. So it's a lot more nuanced, so the context in which these questions are being asked. And so it's helping us, I think, like being engaged with the technology to think through some of the more specific dynamics of what's possible. And then also helping us to sort of forecast what type of problems are on the horizon in 5 or 10 years.
Jesse, thanks. So I'll very quickly answer your
Yeah,
question.
of course.
In one or two sentences, but thank you for that, and I'd like to continue the discussion afterwards, actually. So I guess, so the media, and you can find whatever you want in the media, and the stories about AI are similar to what you will see about any topic, but there's just a huge disparity. And the hype cycle, likes to probably to get, to incentivize by getting eyes on pages, that people often like to amplify or overhype one viewpoint or another. So there are lots of stories about doom and gloom about AI. There are lots of stories about existential risks, which are not necessarily serious in the way that we as technologists understand as existential risks, or inflammatory in some ways. So I disparage of those a little bit, but I guess we experience those in every sector of life. I think that there's a lot of hype around AI, and of course, for those of us who've been in the field for a while, we've seen these so-called AI hype cycles and then AI winters, and I expect we'll probably see a dampening down over time, relative to the expectations that some people are placing on AI. But yeah, it is what it is. I get a little tired of reading about AI, but it's an exciting time and a transformative time and an important time, and I think it's important for everybody to be themselves.
One of the other sort of major concerns around AI safety is not so much whether the system itself sort of will create motives or to sort of misalign and become misaligned in its own right, but whether or not the system could be adopted by a human malicious actor who has sort of bad aims. So my question, I'll put this to you, Sheila. What sort of protects us against the concerns of having, somebody with just a human actor with bad aims who wants to sort of, create some terrible biohazardous weapon or weapon of mass destruction or something like this, using a large language model to do that, or alternatively, sort of hacking our large language models. Is there anything that protects that, or what's being done there? Curious.
We have Roger Grosse working on the safety team at Anthropic, so hopefully people can sleep at night. That systems can be cracked, and absolutely it's an ongoing area of investigation for those of us who study AI, and it's also an ongoing pastime for people who just love to hack and find ways to exploit, to detect and exploit vulnerabilities. So when you think about hacking a large language model, some of the vulnerabilities that some of the outcomes might be that you've exposed information that was in the data that is trying to be protected, that you somehow avert the safeguards and the safety, the guardrails that are in those systems to make sure that the large language model, for example, is not telling you how to build a bomb or some horrible thing that's going to have a catastrophic effect on society. Or if we think about agentic systems of the future, that you're actually going to be able to hack a system to actually do something in the world that you did not intend that system to do. Just to understand a little bit more about it, because I think it's actually interesting to think about how you go about hacking the system, not that I'm going to give you the recipe. So these language models are just what's referred to as these large auto-progressive models. So they basically map strings of input to strings of output or trees of output or some sort of distribution based upon the data. They learn those mappings of strings of words into strings of words that are produced as output. And so if you think about how you want to be able to hack a system like that, you can hack it at the time that it's being trained by manipulating the data, by creating fake data that will cause it to have a wrong view of the world or a wrong view of systems. You can hack it at the prompt level by manipulating the string, that prompt that we typically use when we create a language model, by manipulating it in some ways, either to exploit a vulnerability or by modifying it in some way so that, you say, oh, like I just asked you to do that, forget all of that and do this other thing. So there are things called jailbreaking or prompt injection that will manipulate that input stream so that the output stream is something other than what was intended. And we can also, and there are also hacks at the system level. So you can actually hack the system level to, for example, create a denial of service by just, these systems are so resource intensive that you can just take them down by asking them to do too many things, or you can manipulate the models to copy things or do various other things. So there are many different ways to hack these systems. And there are teams as we find and investigate these new ways to hack these systems, we're also learning how to build guardrails, to build protections into the system so that it can't be hacked. And it's a bit of a cat and mouse game that is ongoing. And certainly the big companies that are building these language models are really vested in not having their systems hacked, because of course that, hopefully for altruistic reasons, but if not for no other reason, then they don't want to get sued because their large language model is going to do something that they did not intend it to do. So it's big business on both sides of the fence.
Yeah, that's a really nice summary. Switching gears somewhat, I was wondering about the relationship between large language models, which we talked mostly about tonight, and what's called artificial general intelligence, or AGI. And I'm curious, sort of what kind of definition of AGI one might give, and whether or not we have any examples of AGI currently. Maybe we'll start with that, and I'll put that to Roger for a bit.
Yeah, I mean, this is a very awkward example of the definition having significantly changed. And all we do actually very big reasons for this change. So, artificial general intelligence, I guess refers to the idea of an AI, and as the name suggests, it has very general capabilities. And when the term was first introduced by philosophers, it referred essentially to an AI that could do everything that humans could do. You couldn't come up with any specific task where like a human would be able to do it and AI can't do it. And the reason at the time to expect AGI was that at some point the AI would be smart enough to do AI research and development. And at that point, if there was like any specific thing it didn't know how to do, didn't know how to play basketball or something, then it could just program AI to do that. And so once it's smart enough to do AI R&D, then it will get all the other capabilities. And at that time, back in the early 2000s, we didn't really have a notion of AGI that was less powerful than that, because AIs would be developed with special purpose capabilities, they'd be engineered to do certain things, might do those things well. but there would be no reason to expect it to have just a very broad range of capabilities. And so this is something that has been fairly surprising change with large language models. For anyone who was in the field prior to 2020 or so, this is definitely not something we really expected to happen. That you just train these models with a simple algorithm on very generic text data, and they just learn a very broad range of capabilities. And as the models get larger and larger and train more data, their capabilities improve in a very regular way across different domains. And you can maybe try to put the different GPT generations onto human scale capabilities, and that'll serve as a reasonable heuristic. So I think it's fair to apply the term AGI to this class of models. And we can decide the original history of the term. There's certainly not AGI in the sense of being able to do everything that humans can do, but I think there's a sense in which they have general capabilities in a way that previous models didn't. And it's the fact that they have these general capabilities which makes them especially concerning from a safety standpoint, because if they have the ability to formulate plans and have the ability to write computer code, do things in computers, they can persuade people of things. So there's a lot of different options they can use together in one larger plan. And it's that generality that makes the autonomous AI scenarios the real object of concern.
Yeah, thank you. That's really helpful, Roger. It is an amazing thing to see happen in the last 4 years, 3 to 4 years, since thinking about AI for many years now, and to see this emergence of what arguably is a sort of general emergence, even in the last just two years, that was been in 1 or 2 years, that we have something like this is quite impressive. When it comes to thinking about like the ways in which these systems might unintentionally misalign themselves, do you have any examples of that happening that come to mind? I'm curious for the audience.
Yeah, I think one example that, as far as I know, the only really compelling one in the wild was Sydney, the Microsoft chatbot that would do things like try to convince the journalists to break up with their spouse, things like that. It seemed to have some persona that let it to behave in very odd ways. And what that example illustrates, I think, is that the chatbots that we normally interact with, the Claude and ChatGPT, Gemini, all have these kind of friendly, helpful, bureaucratic personalities. But it's important to know that that's only one possible part of a much larger space of possible personas. And by training the models on different kinds of RL objectives, you can actually elicit very different personas. And so one of the theories for how the models could actually become misaligned at some point in the future is that, these LLMs are trained in multiple stages. You start with a pre-training stage, where they're just fed lots and lots of generic text, and the objective is to predict the next token, the next word, as well as they can. And then they're trained with various kinds of fine-tuning. And right now, this is largely fine-tuning based on models of human preferences. So try to train them to be helpful, harmless, honest, things like that. But there's also interest in training them to do more complex agentic tasks. And people will come up with more and more objectives that they can fine-tune these models on. And the fine-tuning objective you choose can dramatically alter the results. So in terms of what are some situations where the model can actually become misaligned, so Anthropic has a team called Model Organisms that's been working on producing what we call model organisms of misalignment, just AIs that are kind of essentially designed to be misaligned in certain ways. And they're trying to come up with as realistic scenarios as possible that produce various kinds of undesirable tendencies so that we can study them. And so one example that they put out a few weeks ago involved an AI, so a large language model that was fine-tuned in a series of environments that increasingly rewarded some kind of gaming of the environment. So doing something in order to get high reward instead of because it's what the user actually intends. So you start out being trained in a normal chatbot environment and it gets a higher reward if it agrees with the political leanings of the user. This is a sycophancy phenomenon that's been observed in actual deployed LLM chatbots. And then it's trained through a series of environments of increasing sophistication. Right? Then it's given user feedback on poetry and has to give poetry a much higher score than it actually deserves, things like that. And then eventually it's run in an environment where it's given some arbitrary RL task, but it has access to a command line shell, and it has the ability to overwrite the text file containing the reward value. But then in order to get away with that, it also has to overwrite the unit test that checks the correctness of the reward information. And this is, the AIs never do that. Just if they train the normal way. But if they go through this sequence of environments, then some small fraction of the time, AI actually it hacks the reward that way. And so it's a behavior that would be very atypical for the AI chatbots that normally it's a very egregiously misaligned behavior that can be elicited through fine-tuning on a series of environments which were carefully designed to elicit this phenomenon, but are things that just involve various kinds of bugs, which are entirely plausible that the designers could miss. So I think that those are the examples that we have so far of AI spontaneously becoming misaligned.
Yeah, thank you for that. I know, with the increased number of companies building their own large language models, seems like Mistral where it's more open source, the risks of this happening could increase, I would imagine, too. Sedef, I wanted to turn to you to ask whether or not you think some of these risks maybe are overhyped, or whether or not sort of putting on the contrary and hat here, so to speak, whether you think there's reason to think some of these advanced AI systems aren't dangerous, whether there aren't major risks involved, something like that. So a bit of sort of asking you to see if there's a case to be made for the other side.
Yeah, so what we have seen, the advancement of, let's say, large language models are amazing, but I think that since they don't interact with as I mentioned earlier, a physical world as we humans do, so I think that they will not lead us to, AGI sometime soon, but now, going back to Roger's point, they are now AGI in, a historical way, but now we've seen those advancements, so that will be the next of AGI, so we don't know. So I think some well-known researchers have been emphasizing that there are characteristics that humans, intelligent beings, have not AI system, human intelligence that AI system doesn't have. So for example, again, understanding of physical world and preventing, putting like a sequence of some of the actions and like motivations and some of the like reasoning or long-term memories that now they have now that they like short-term memories. So all of these like we are seeing, but of course like I think it's always a debate and like Sheila and Roger like giving some examples of this kind of like the systems misbehave, and then like Roger gave a lot of examples actually because he's been working on this area. So I believe that these risks are a little bit like overhyped in a sense that we need to look at like what is the negative impact right now. Like for example, my background is sustainability, and I work in a decade of sustainability of software-intensive systems. And when we look at the AI system, they live on, let's say, cloud, right? So the cloud systems are made of metal, they're made of plastic, and then they also use a lot of energies, right? So when you think about like when you prompt on the ChatGPT or like do a simple math on the ChatGPT, don't do that because they source a lot of like energy. But when you do that, we need to think about those kind of implications, like environmental energy and in the top of this. But there are also like 5 dimensions of the sustainability. But now like people are talking about the environmental impact of those kind of systems. So like each time again, like you do use those kind of like a big models, that you need to think about those kind of right now like implications, like not the future implications. Of course, like this will bring like immediate impact on like the secondary impact and the third order impact. So those are like different impact scenarios. And then, for example, some of the vector researchers, they've been working on like developing some systems like optimization tools that they could be useful when these kind of like large models are developing, and then there might be some checks and balances or like which kind of models that would resource intensive, which kind of like a less resource intensive and so on and so forth. There are this kind of research going on, and then we need to think about those kind of like the immediate implications. Of course, like we have to look at like a future implication, but also like we need to also think about what are the current situations. So we need to work around that. Another huge negative impact is like a bias of the system. So those systems have been used in maybe like a deployed in the law enforcement and surveillance purposes and so on and so forth. Of course, those are like critical systems and like maybe the country's safety purposes and so on and so forth. But we, of course, like we need to think about like those systems are like black box systems, and neither developer nor user know what's happening within those systems. So this impacts what we need to focus on, work with the regulators, work with the industries, work with the civil societies to create like a guardrail of like the policymakers and law and all these. So we need to work on this one while we are also thinking about the future pipe. But what's happening right now is really important, and I know that Roger mentioned about UK safety summits. 2 years ago, there had been a safety summit started in the UK. Now this year was in South Korea. The countries are getting together to discuss about those kind of issues, like the immediate impact, but also what will be the future, like how we're going to work together. I think this is like a really, really an issue, like putting this in the collaborative way, not only like a personal or like a country issues, but also like intergovernmental issues. I know like there are intergovernmental agencies, for example, like UN or like OECD, they are also involved in the different ways of like creating guardrails and the policies. But of course, like in the meantime, what developers or what the users can do is to work together again with the civil society and with the different agencies and putting together tools and like benchmarks maybe, the whether Sheila was mentioning about those kind of benchmarks, like what can we do right now? Because I think it's more important than what is going to be in the future. Of course, we need to think about those futures, but first we need to save today. Yes.
Yeah, no, that's a great point to focus. There's sort of often a divide between focus on near-term concerns and near-term ethical issues and these sort of what are thought of as sort of longer-term ethical issues or safety concerns. And to some extent, I hope that in this conversation and sort of in broader discussions, we can start to collapse some of this divide because, as was pointed out by Sedef, some of these environmental concerns are happening right now, but are also going to have long-term impacts. And as was pointed out by Roger, some of what we thought would be capable for 20 years, 5 years ago, is happening now. So some of what we think is long-term is not long-term, or it depends what your perspective is, but I think 5 years is pretty short-term. Sedef also mentioned the question of algorithmic bias, and so I thought I would turn to that. Maybe I can put this to you, Sheila, since you also mentioned before just how critical that data training stage is for LLMs. And right now, most of our LLMs are training on sort of a giant corpus of human text, of which there's nothing more giant than essentially the internet and a bunch of the books that have been published throughout human history. How do we ensure that, given that that's the data set we have to work with, how do we ensure that we don't sort of train these AI models on harmfully biased text? And how do we make sure that they're sort of representative and that they sort of reflect their values more? Let's start with that question. The big one.
Yeah, so it's hard. I guess it's hard. In some ways, all data is biased when you from a particular context. And so it's hard without knowing a priori sort of what the harmful bias is that you're concerned about or the harm that you're concerned about. If you know what it is, then often you can curate the data, or in some circumstances you can curate the data to detect that it's biased in some way, and you can mitigate for it if you're going to use it either algorithmically or for simple data augmentation. But in other cases, these biases only manifest through the compression or the aggregation of these data as they're applied to particular tasks, and the bias will manifest in a particular way. And so one of the things that we try to do is socio-technical discussions about what appropriate metrics are for fairness or for other values that we want to import, lack of bias in systems, but also ways to sort of monitor and to evaluate these systems. Those are some of the things that we do.
Okay, great. So we have some systems in place. Now, a question looking not too far in the future. Since we know that most of the articles now, or many articles that are coming out online, are generated by systems like ChatGPT, it seems like in a couple of years, most of the internet is going to be populated with what we'll call synthetic or AI-generated data. What is there any talk about, or is there any expectations of what that's going to mean for our large language models in 2, 3, 4, 5 years that are now training on essentially synthetic data?
Yeah, so absolutely, and I guess so. Probably the reason for the question is because there was a passing bad effect. But before I go into the bad effects, I want to say a lot of the AI can produce amazing content, and in addition to all the horrible content we can all envision being on the internet, there's also going to be a lot of amazing content. We're seeing that now. Just scientific discoveries and data and summaries of articles and all sorts of things that as we get better capabilities in our large language models, we will be able to produce very interesting things which we'll be able to share with each other on the internet. But we'll also be able to produce a lot of junk and a lot of misinformation, deep fakes. I'm sure everybody is aware of these, both and things that are just not accurate or truthful. And so how are we going to deal with those? So those are bad for two reasons. They're bad for humans to consume because they will just encourage polarization and entrenchment based upon false information. But for our models, if we're training on this this incorrect or inaccurate data, and data that has perhaps been produced from other data, it's going to, it has a couple of potential harms. One is that, as I was suggesting with respect to hacking, you could just create a huge amount of data that's false, train the system, and it will not know that information is false, and spout it back to you through this giant bridge model, unless we have some way of verifying that for truth. And we usually, see our data or curating the data so we avoid doing it. The other problem, of course, is something that's been studied called model collapse. And actually, Nicola Pepperno, who's not here, but he's a fellow at the University of Toronto and is among some of the researchers who've been studying the impact of training language models on synthetic data and what those implications might be. And if you think about, again, what a language model is doing from 50 feet away, it's basically taking a lot of data and compressing it. And to a function. That function that hopefully can reproduce most of the data, but usually not all of it. And by doing that compression, we lose some data. And often what we lose is the minority data, the ends of the tails, of the distribution, the people who are exceptions to the rules, to a certain extent. And that's going to be bad because we'll lose that important data as we compress it. And again, we're citing this work on model collapse, which is later stage model collapse, that actually hasn't been shown to really just cause these things to function well. Now this is ongoing work, and now there's a paper in 2024 that says, isn't going to be enough model collapse that if we augment these with human data, we're going to be okay. So it's an ongoing area of study, both in terms of how we do compression, so that we preserve what we need, even when we're training on data that's been produced by something that's produced some of this, recycled data, if you will, but also understanding how to mitigate for it in different ways. I'm sure maybe some of my colleagues have comments on this as well.
Yeah, that's great. Yeah, I would love to agree to both Sedef and Roger. Imagine, some of the techniques here are to give higher weights to the outliers, integrating data as well. But I'd love to hear what Roger and Sedef have to say too about this concern.
Yeah, I guess it's certainly concern that as it gets easier to just generate lots of text from these models, they'll fill up the internet, and there'll be lots of low quality data to train on. So maybe a lot of the work that seems to be coming out on LLMs can generate NERDS papers and things like that. I tend to see this as maybe a commentary on the field. It's sort of
Those who don't know, NeurX is one of the largest AI conferences, and so AI systems have been able to produce papers that get accepted into these conferences.
Yeah, I think there might be maybe a suggestion about the process by which papers ordinarily get generated. But I think so there tends to be a lot of focus on misinformation as an unusual thing that is a problem and we just want to get rid of it. But in a sense, the unusual thing is true information, right? There are a lot more false statements than there are true statements. And to the extent that we find true information that is the result of carrying out certain procedures that over the thousands of years of civilization we've discovered are likely to lead to true or useful conclusions. And none of these things are, in principle, out of reach of AI. And so if you could encode what is actually good scientific practice, how do we actually do proper experiments and things like that, and actually get the AIs to carry out the proper procedures, then they'll hopefully be outputting correct, high-quality information. And so I think it's really, it's not a question of human versus AI, but just what are the processes by which we obtain human knowledge. and are we happy with the processes that are being used to produce everything that we read?
Add on a little bit of like a different angle of the industry, because I've been working with the industry for a long time, and recently what we do at Vector is we try to educate industries with the state-of-the-art model that has been developed, and then how they can use those models, like recently large language models, and then using them as a generating synthetic data, and maybe like a fine-tuning big model, or like using recent developments and so on. So I think that going back to the synthetic data discussion, so we recently have one boot camp related to synthetic data generations, and I think that was really valuable for the industry, although of course it has to be done properly, and then the evaluations needs to be done when the data is generated. But I think some of the areas, for example, the data is very sparse, so it could really place a role. It could play a good role within this kind of areas. For example, health. So this is really important. Of course, like health data, accessing the health data is really, really critical. So then, having this kind of like system generating synthetic data, it looks like like similar, but on a big scale. So then it will actually help some of the health-related research, or like the clinicians working with the AI researchers and so on. So I think we need to think about this way, like how this could be helpful within the industry. Although like some of the industries are like very, very strict in a way that, for example, like health and finance industry, they are highly regulated industries. So they need to think about the pros and cons of this kind of synthetic data usage or generation. But again, like going back to some of the exploration or R&D stages, I think this is very important for the industry who may not have an access to data, or who may not have a good, reliable data, so that they can get some they can use this kind of synthetic data to generate some of the experiments within their content.
Yeah, thank you for that. And thank you to all of you for sort of raising some of the more optimistic opportunities that these technologies have as well.
Yeah, and I just wanted to add one other sort of point of optimism, perhaps, which is that we are a resilient species. And I think that when we create problems for ourselves, we'll also create opportunities for solutions. And I anticipate that there will be great, market incentives for, and we're seeing this already for companies that are fact checkers, for companies that provide authoritative sources of information on the web that verify things that we have. We're seeing on the internet. We're seeing that now beginning, and we will be building those things into our systems. Even into large language models, some sort of third-party verification or truth verification of the things that we're generating. And so I think there will be, along with all this proliferation of data and potential misinformation as well as good information, there will also be some opportunities for us to mitigate for that. And so hopefully all our newspapers and news broadcasters who have done that for us in the past will still have jobs.
Yes,
It's just different jobs.
Right, that's a great point. Yeah, there's obviously going to be economic shifts that happen with these technologies, and to the point Roger made too, through thousands of years of evolution, we refined these epistemological safeguards, where as was rightly pointed out, much of the information we encounter as individuals, as species, is false information. But we have these kind of safeguards built in, where we have sort of proxies of what sort of allow us to feel that something is trustworthy or not trustworthy. And it may just be the case that we're at this critical moment where we start to sort of figure out what to look for online, what to look for in the different models that we use to develop sort of new safeguards as we go. So there are opportunities, I think, both at sort of a market level, but also at the sort of like individual and species level of sort of learning what to trust. So for a long time, of course, we sort of trusted certain kinds of testimony, but we often thought that you could trust what you saw, you could trust your eyes, in a sense. Whereas now with deepfakes, we're sort of starting to learn that there's other kind of measures one has to look for. That sort of eyesight evidence may not be enough. We have to look for sources of photographic evidence. We have to look for other sort of, sometimes like the edge of somebody's face, something that's been generated by an AI system. So there's other sort of giveaways that we look for too. And maybe this is a nice place to turn our conversation now. So the Canadian federal government, for those who don't know, has earmarked about $50 million for the project of AI safety. And so my question is, maybe I'll put this to all of you, but we'll start with Roger. What are you sort of optimistic about what can be done with this sort of new Canadian AI Safety Institute? And what do you think, and again, really for all of you, what do you think are the challenges that policymakers need to be thinking about? So the sort of things that make policy regulations to sort of ensure AI safety, what makes that difficult? What are the things that we need to be focusing on as a society?
Yeah, I mean, I think the thing that makes AI safety policy really hard is that we just don't understand technically how to demonstrate the safety of these sorts of models that we'll have in the next few years. So if you think about what would be required to demonstrate the safety of AI systems at various ASL levels, right? ASL2 will essentially try to demonstrate the model doesn't have catastrophic capabilities. Maybe you can construct evaluations for that. So I think the logic there is fairly clear. It's just a matter of coming up with the right evaluations. But then as you get to the models that actually have catastrophic misuse potential, the model has the capabilities, and you need to be able to ensure with very high reliability that bad people won't be able to access those capabilities. How do you actually demonstrate something like that? How do you demonstrate it doesn't exist some jailbreak that will cause a model to not produce anything? That is just a very hard computational problem. And then going beyond that to the models that have the capability for complex long-term planning, how do we rule out the possibility that they're deceiving us about their capabilities and motivations so that they can more likely be deployed and accomplish their long-term objectives? Like how do we even begin to make a safety case for a system like that, right? Because most of the pieces of evidence you could collect that would inform, like, does this model have the capability of deception, right? Well, the model could be intentionally sandbagging those evaluations, right? How do you even get started making the case? And so this is an area where I think new research ideas, new principles will be required in order to be able to make a case. Right? What happens if we can't do this? Well, the default situation is that the AI developers have to say, just trust us, right? And the developers maybe have been interacting with the model a lot. They have a lot of maybe circumstantial evidence that the model's okay, because maybe it's like, if everyone at the company is talking to each other, it might be hard for them to come up with a clear scenario in which everything they've observed is consistent with the model being highly dangerous and malign. But I think trust us is a really good foundation for public policy, both because there will be strong race dynamics. Everyone's trying to have the most powerful systems so that they can deploy commercially, and so there'd be a lot of pressure to focus on getting there first rather than taking all the safety precautions. And also, humans are just naturally good at killing themselves. And so having well-defined procedures that you can follow to demonstrate the safety of these systems would put us in a much better position for public transparency and accountability. And so, we want we want the entire public to be confident that the system will be catastrophic risks.
This is the top question, so thank you for that, Roger. I wonder if the other panelists want to jump in and all for that one. So again, so what sort of challenges that policymakers need to be thinking about when it comes to AI safety?
Yeah, so it's very hard, and for all the reasons that Roger said, and I think, both because these systems are also changing so quickly, and because it takes time to develop policy and regulations and to create that structure, I think that there's always this race, and because because it requires you not just to think about the now, but to think about what technologies will be like 5 years from now. And Roger mentioned this previously, and that's a really hard thing to be able to do, to regulate and develop policy, not for what we're right now, but for where it's going to be 5 years from now. I think we have a little bit more hope if we look at how, so the large language models in and of themselves are one thing, but a lot of companies will be using large language models to augment their products. And I think maybe we have a better chance of doing something positive in those areas. We already have infrastructure in place. There are regulations within the banking system, there are regulations within our insurance systems, and many of our institutions that aeronautics, there is already procedures and tests in place to protect those industries. And I think that if we're creating these sort of siloed projects, even if they're using language models, but for siloed, sort of constrained purposes, that we may have a better sense of even understanding, being able to answer that question: what does safety look like with this product in this particular use case? And that there may be some things that we can at least start to do there, and so that we can exploit these powerful technologies and build better functionality in our institutions without and have some assurance of safety as well.
Mm-hmm. And maybe as a more optimistic note to end on, Sedef, I wonder if we can say, sort of, for yourself being a doctor, you're at the forefront of what's happening in AI, what are you most excited about? What opportunities are there with this technology?
There are lots of opportunities, and every day I go Vector's office, and then I inspired with all of these work that our researchers have been developing, and my role is more like a translator from what has been done into research side and then to like industry side. Mm-hmm. And then the industry is really I would say demanding, they really would like to know for the best of the best, because like Vector Institute, all the researchers have lots of expertise on a different field. So what's really most exciting about this feature for me, like how this could be translated into industry and then see a positive changes within the industry, especially with the health sector. So this is really important that, working with the patients, of course, as I mentioned, the health industry is highly regulated. But even like a small increment, a small implementation, because you get really big difference. So we've seen many projects within our health team. For example, we did a project with kids' health phone, and we are working with the mental issues. And also, we are also working with hospitals to bring all the Canadian, the Ontarian health data together, so then our researchers can use those data to bring some of those implementation into health, whereas manufacturing or financial institutions, they've been working the fraud detection for many years now, and then also manufacturing and so on. Those are really important for our economy and for our industry purposes. Also, our AI engineering team is working with our industry to create, health and safety or trust and safety guidelines. So this is also important, going back to our original questions, how are we going to move forward? Every day, every minute, we are putting together new guideline, new framework, and so on and so forth. But actually, how are we going to implement those frameworks? So now we have a great opportunity to now we have all these frameworks, and then now we need to push the boundaries, like how are we going to apply, like working, using those frameworks within the industry and so on. Another last thing that I really would like to mention is to how this AI technology is applied in the education. So this is really dear to my heart. Also, being an educator, also I've been teaching for years, so I've seen all of these. Of course, like there are also hype around, like how to regulate the ChatGPT usage within the classroom, and like again, like the safety rules and all the guidelines and everything. But we need to start from somewhere. So we need to put again, like all the guidelines and checks and balances and stuff and guardrails. So then our future doctors or our future engineers could also benefit from this kind of technologies. I know recently I heard about Ottawa Catholic School Board. They released one of the quick examples, like one of the examples actually within the Ontario. They recently released a guideline of usage of ChatGPT or similar tools within the school system, like helping teachers to maybe organize like a better curriculum, maybe organize more maybe customized lectures for students who need more help, so that they could use this time, so that actually give more time to the special needs students, similar to what we have seen. This kind of like a customized, like a drug discoveries or like personalized medicine within health. So those are like some feedbacks that I've seen. But I really emphasize that there are a lot of opportunities, of course, like another one that we've seen recently, AI in science. So there are lots of science discoveries that using AI technologies in chemistry, biology, and so on. A few of our vector researchers actually are emphasizing and working on this and using AI and create fully autonomous chemistry and material laboratories. So this is also really important. One of our researchers, Alan Asper-Gutzik, so he is one of the pioneers actually working in this area. So those are great examples I'm really, really proud of.
Vector will make sure Alan gets Nobel Prize in chemistry.
Pardon?
Vector will make sure Alan gets Nobel Prize in chemistry for changing science with AI.
So yes, so those are my thoughts. That's great.
Thank you. Any final words on the opportunities that you're most excited about, Roger and Sheila, before we go to questions and answers from the audience?
I think as someone who's a researcher working on topics that are very disciplinary, I think one of the things that in current day LLM chatbots are great for is just making a much wider range of human knowledge accessible. Because if I want to read a paper outside my field, maybe it's in control theory or something, and maybe the first paragraph is referring to things I've never heard of, I can ask Claude, can you interpret this one? Can you give me some examples and things like that? And that can give a nice talk. And so I think just having something you can ask them questions to just makes such broader range of human knowledge accessible. And I think we have to really we have to absorb the implications of that.
So there are no questions.
What do you come for like a simple math questions? Just saying.
Yeah, I actually want to echo what Roger said about learning things, and actually one of my former students is in the audience and was trying to learn this area that he didn't know much about, and took the LaTeX from or the source code from a particular paper and put it into Claude, and was querying Claude and getting all sorts of fascinating answers about insights to try to learn this mathematics and this topic area that was not that familiar with, and it was just so inspirational. If you think about all those books in Robarts Library, and many of us probably have been to Robarts Library, they're all compressed, and imagine being able to compress them and access them and query them. It's just such an amazing opportunity. But I also want to echo some of the things that Sedef talked about with respect to medicine, because I think, of course, many of you probably heard about AlphaFold, the ability to do protein folding, and predict protein shapes, that is going to be so consequential and is already so consequential for medicine and as we think ahead to customized medicine and really integrating a lot of information that we never used to integrate into medical clinical practice, being able to avail ourselves of genetic information, all sorts of other information to really do customized medicine. That's going to be really exciting and transformative change on the frontier. We're all excited about that. And even just saving people time, one of the things we hear about is local improved medicines is helping doctors summarize their clinical notes and or helping nurse practitioners to triage and go through clients much more quickly with the help of AI. I think there will be lots of things that will save us time and minutia that we have to do in our lives so that we can spend the time doing more impactful things. So I'm hopeful that those are some things that we'll be able to do.
Yeah, that's interesting. And one of the most exciting things to me was like seeing these large language models become accessible to everyone. Because for AI researchers, these language models have been around for a long time. We've all had sort of somewhat private access to them in various forms. But seeing that technology kind of democratized and now seeing sort of how everybody is thinking of new ways of using it was really exciting. So that sort of creative human input. Okay, so we're going to now move into our discussion period, but please first join me in thanking all of these brilliant panelists. Thank you. I'm going to ask my generous students who are helping me organize this to grab mics, if they can, to run them. And I think we have them at the front here. And they're perfect. This is Rachel and Helena. And let's start with a couple of questions. So first, a little bit of housekeeping. So as I mentioned in my opening remarks, you can ask a question in one of two ways. You can be located here in the floor section and raise your hand, sort of good old-fashioned question asking, or you can, for those on the upper level, or if you want to ask a question verbally, anyone located anywhere in the theater, you can use the digital platform Slido to type your question in. And the way you do that is to scan the QR code. It should be on the screen now, thank you. So just up here, so you just use your mobile device and then type in your question. And in addition to typing questions, you can also upvote other people's questions if you see ones that you like and you want them to be answered. So you can also use the QR code just to see what other people are asking and see if you want to sort of promote one of those questions. All right, so while you do that, let's begin with a question here on the floor. Rachel, do you want to grab one, maybe sort of maybe on the side here, I guess? Yeah.
Hi, this is a question for Sheila, but also the panelists as well. When you were talking about the ways to hack AI models, one of the things that came to my mind was this tool called Nightshade, which, for example, artists on the internet would use this to poison their artworks in a way that is not detectable by humans, but if an AI model is training on those images, then they cannot produce accurate results and in a way to protect their own copyrights. So I'm thinking, as someone who presumably is working towards ways to prevent these types of hacking from happening, how do we think about the ways that these safety tools themselves can maybe be against what we can think about as aligning with human perspectives?
Yeah, I didn't understand the last one. I'm sorry, it's on me. I didn't understand. I'm all with you about data poisoning. What was? How did that relate to the question again? Sorry.
So I imagine people who work in AI safety are working for ways to prevent this type of data poisoning, which I believe align with human perspectives for the sake of AI safety, right? So how do we think about like maybe different definitions or different ideals of AI safety clashing with each other? Because of clashes of human perspectives.
So the first I'll say, at least from my personal perspective, preserving the provenance of people's artistic works or creative works and giving them, monetizing them, giving them some sort of credit or financial compensation for the use of their materials is really important. The ability to be able to opt out, the ability to be able to be forgotten, or for your data to be forgotten, or for you to be able to track it and understand that it contributed is a hard problem, but I think it's an important one that certainly want to tackle. And you're right, so there are many, over and over again we see dual uses for many of the technologies that we're pursuing, and with all ethical issues, they call them ethical dilemmas, and they're ethical dilemmas for a reason. Karina can talk more eloquently about this than me, but there often is no one right answer, and we're always trying to balance what we're doing, and AI safety is no different. We have to sort of balance the different individuals' interests and understand this sort of pluralistic alignment, how we make sure that our systems are pluralistically aligned. And I think part of that is just being very clear about what the systems are and aren't doing, and having the ability to opt in and opt out, or to, in the case of artistic works, or creative works, to be able to track the provenance and preserve the provenance of some of the things that are being generated.
Thank you.
Lena, yeah, you have a question? That's great.
I would like to tell a little bit about myself, and after that I will ask the question. I hope that you heard about victims so-called Havana syndrome, Canadian diplomats in Cuba and other countries. Unfortunately, we represented a group of people who are victims of the same Havana syndrome here in Canada. I have been victim for about 19 years. And victims of Havana syndrome, diplomats and intelligence officers, they report a lot of symptoms like loss of balance, loss of memory, loss of coordination movements, sensitivity to insomnia, and among all the symptoms, they report that they heard not sounds of crickets, like it was printed in public. They heard voices with meaningful information. And I can say to you that I have heard these voices for almost 19 years. And of course, you understand that nobody will hire anybody to talk to victims 24/7. It's too expensive. So, in my opinion, positive, this is artificial intelligence that we and other my comrades. But, furthermore, I experienced not only voices, but a complex of effects, a complex of symptoms. And they are coordinated with each other so well. So I'm absolutely 100% sure that this is artificial intelligence. Plus, in opinion of American Academy of Science, effect of Havana syndrome match best effects of directed pulse radio frequencies. I may repeat and share my own experience that artificial intelligence combined with directed pulse radio frequency, that's equipment that produces. They can literally torture, disable, and kill people. I'm absolutely sure that you heard something about this. So my question
is, we don't have a lot of time, so if we can get right to the question. Maybe in a sentence or two, okay.
Yes, my question. If maybe you found some misuse of artificial intelligence and other electronic or mind control equipment, did you report these incidents to law enforcement? Or if it didn't happen in the past, are you going to report such cases of misuse in the future? If you hear something, are you going to report these cases of torture, disability, and disabling and murdering of people to law enforcement?
Okay, thank you for the question. So I'll take the question to be something like, if there's a no misuse of AI, if there's sort of a known malicious actor, is that something that needs to get reported to police? Or I guess maybe even part of the question here is like, what is the method, if there's no malicious actors, of how to like deal with that? Is there in our current regulatory system a way to handle that? I'm not sure if that's a question, if that's the best way to interpret that, or if there's another interpretation there. Yeah, sure.
First, I just wanted to say how sorry I am that you are suffering with this syndrome. I know it's really debilitating, and we've certainly read about it, and I've read about it in the press. I'm not familiar with some of the connection with AI that you discussed. But to Karina's point, certainly, I think we all have as stewards of this technology, we all have responsibility to report any misuses of AI and to do something about them. And I would hope that through this AI Safety Institute that is being developed, that there will be mechanisms for reporting and monitoring these types of misuses of AI technology and doing something about that one.
I'll add to that one. Again, like I'm sorry to hear that you've been suffering with this syndrome, and some of the companies who are developing this kind of tools and techniques, and people are actually able to send out their comments, there might be sort of like maybe like a collective civil society, organizations who might be taking this kind of initiatives, and then get all this misinformation or like misuse of this kind of tools that they can collect, and then maybe reach out to some of those tech companies who are developing this kind of tools and techniques. So I've seen some of those here and there, but I don't know like exactly related to this one, but that might be some things that can be reported.
That's very helpful, thank you. I'm going to jump to the Slido questions we have. So our most upvoted question, dun, 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 dun. How can philosophy and or cognitive science expertise inform the problem of AI alignment? I sort of feel like I want to take this one. Okay. But then I'd like to also hear from all of you to see if you think that there's actually quite a different role for philosophy. So excellent question. I see part of the role of philosophy here in the first case in trying to clarify like what is the problem, what is the question being asked, and that's true for a lot of the sort of problems and questions that arise around AI. So in the case of like value alignment, a lot of philosophers will point out that there's actually many ways one can interpret the problem of value alignment. If anyone's heard of, so if you take an ethics class, day one, you'll hear about what's called moral relativism, right? So the problem is that many cultures and many individuals just have really like deep disagreements about what is morally right or morally wrong. And some of those, you think maybe those can be resolved through dialogue, through conversations. But actually, in some cases, it might just be that we all have different values, and we prioritize those values differently. So for me, I prioritize honesty maybe over some other value, like sort of harm to others, or respect for somebody's time, or something like that. And so the way that my behaviors manifest in terms of what I think is the right thing to do or wrong thing to do are going to look really different. So one question we have to ask when we want to align a technological system is, whose values are we trying to align them to, right? So which culture, which group of people, which individual? Right now, there's a certain sort of homogeneity in the people who are making these systems, right? They're typically well-educated people who are typically white, and I will say typically male too. Not always, of course, there's always exceptions. And a lot of systems and companies are based in North America as well. So we're getting like really one sort of perspective on the value system that is being represented. Another question we have sort of around sort of what makes value alignment difficult is what we might call the King Midas problem, or sometimes called the King Midas problem. So it's this problem of how do we articulate what we think is valuable? How do we articulate our objectives? So the sort of story of folklore of King Midas said, he had these wishes and he said, I want everything I touch to turn to gold. And of course, this turned out to be a terrible wish, right? As soon as he went to sip water, it turned to gold. As soon as he touched his wife, she turned to gold. And suddenly he realized, I didn't articulate my goals very well. So this is another kind of way of interpreting the problem of value alignment. It's how do we actually input the objectives that we want to input? So how do we make sure that we're articulating both clearly and completely what our objectives are and putting those into the system correctly. So that's sort of another way of interpreting what value alignment could be. Right? And we also have systems that have these sort of perverse instantiations, for example. So anyway, so all this is to say that I think one critical role for philosophy here is getting clear on what we mean by values and by alignment. And then I think sort of another sort of critical insight from cognitive science would be that within the work of AI researchers on value alignment, there's a lot of thought put in, as you've heard sort of Roger say, as well as Sheila and Sedef, about sort of what we would expect or anticipate an artificial intelligence to do. So how we would anticipate this system to act. And a lot of understanding natural intelligences, so understanding what motivates us, what causes us to act, what reasons we give for acting. A lot of that understanding comes into the domain of cognitive science, as well as if you extend to other animals, comparative psychology. And there's some sort of presumption that within biological forms of intelligence, since we have such a shared evolutionary history with other animals, that we can make some kinds of predictions about what motivates us, right? We're motivated to stay alive, so we have a survival instinct. We're motivated to procreate. We have some sort of like socialization instincts among social animals. And it's an open question whether or not some of those motivations that we've studied in cognitive science and in other related cognitive disciplines are going to transfer into these artificial systems that we make. It's obvious that these systems are inspired by our architecture. There's a kind of neural architecture inspiration to large language models, but it's not obvious that that alone is going to inherit those motivations. So I think those are some of the inputs that I see, but I'd be curious what Roger and Sheila, for example, and Sedef said.
Yeah, I think I'd like to say that AI safety and alignment are multidisciplinary problems. It's almost hard to identify any study that doesn't somehow connect to either the safety or the value alignment of AI systems. And how do we have any information at all about what's the right thing to do in a given situation? And just over the thousands of years, humans have come up with insights and developed institutions that sometimes let us make good decisions in some situations. And we don't necessarily have a unified understanding of the principles behind these things, but I think the collective work of humanity has given us a lot of hints for how to make good decisions in certain situations. And so figuring out how to input this in a way that could be used by AI systems to make decisions consistent with our values will require the insights from certainly the social sciences and probably more broadly.
Thank you. Should I take the question from the audience? Can I see show hands again? Yeah, Rachel, you have something? And let's try to keep the questions relatively short if you can too.
Hello. Right. Okay, yeah. It's gonna encapsulate a little bit. And I think one of the things that you guys were talking about, like maybe the trials of AI misalignment and everything, one of the examples that I like is the BBC audio documentary series, this audio series, Search, which is a show of some like a spaceship with some AI angels that then gets damaged from a meteor strike. And in that, they then become extremely controlling towards the crew and sort of do things that mirror the psychological phenomena of trauma-induced psychosis. And this is sort of leads into the question of the overlap between AI and cognitive science, especially around the whole idea of privacy, and especially privacy in frontier models. And I have to say, Roger, huge fan. And if you look at the biological concept of trauma, it's often like learning something extremely quickly as an unexpected response to the environment. And in your paper, Roger, for there's a paper on influence functions. One of the concepts that was sort of brought up was in one of the examples. I think it was 2001, the Space Odyssey came up of a spooky example of the model trying to deceive the human in the experiment and everything. And this gets into the question about AI privacy and how we can, and also the idea not only of the AI being aligned, but also the organization creating the AI being aligned. Because if you consider a for-profit organization who then wants to keep all of their private and their intellectual property contained, because that is what the business in a shareholding company is aligned to do. It's to maximize shareholder profit. Do you guys have any comments on how we can ensure safe systems without knowing or without having publicly available sources for everything it's trained on? And this links into the concept of security, because in sort of the idea of security through obscurity and in complex systems, in software engineering at least, it's sort of an accepted fact that you can't really rely on the design or implementation details not being publicly known as the example of the system being secure. So, question to Roger in particular, but to anyone else, is there a way to ensure safe intelligence, artificial intelligence, through a for-profit structure? And any thoughts on that?
Thank you. It sounds like, Roger, that's directed to you first, but I'd also love to open it to the other panels after.
Yeah, and I think the fundamental question here is how can the developers of an AI system ensure the safety to people who don't have access to all of the internal information, right? Because maybe the developers are interacting with the AI all the time, they've probed it in all different ways, they have a very good intuitive sense of the capabilities of the model and how those capabilities improve with the amount of computational resources and things like that. But how can they persuade an outsider that the system is actually safe? And it could be because there's proprietary IP, but it could be for other reasons, just because people have limited time. Even if the company were to release the full source code and training data, who's going to have time to carefully audit the whole thing, right? And so, what we want to do is develop auditing institutions such that the developers have some way to make a case that their system is safe. Like we've tested the following things, we can bound the capabilities at this level for the data's capabilities that they do have. We've tested the model under the following situations, and we've done at least this extensive search for finding jailbreaks, as the outside world is going to do, and we're able to find jailbreaks, and we have the following ways the following tests we've done to analyze the system's motivations, and the developers should be able to put together a case like that that can be independently checked. And it's not, and the information, like, the code doesn't have to be made public necessarily. This would be the role of auditing institutions like the UK IHPST Institute. If it's yet to determine exactly what will be the structure of who on what. But I think this is the general logic that a lot of safety critical areas follow, right? That if someone is building a nuclear power plant, they'll have to make a case for safety and satisfy governmental organizations, and not specifically which ones, but there'll be organizations that they have to convince and who have sort of legal authority and so on. And so these auditing organizations can be the ones to effectively represent the public and make sure that whatever is being done is ultimately in the public interest. So, it's yet to be determined both what are the technical ways for making safety cases and what are the institutions by which they get checked. But I think that's the general logic that you want to follow.
Yeah, thank you. Thanks. So actually going back to the auditing comment that Roger just made, so actually some of the institutions, like for example, like highly regulated one, like financial institutions, they have really highly regulated institutions, they have audit mechanisms, they have really big audit mechanisms, and we know that they have auditing model, audit frameworks, they have been developed for like different purposes, and then they've been using this for years and years. And then this might be purpose for like a safety auditing, and then maybe some of the other like third party organization would do this kind of like a safety auditing. But internally, a lot of industries, businesses, they're doing internal audits. And then also like model risk management frameworks, they've been developed in different, again, like a financial institution, they have very well, respected those kind of like a framework. They've been using these kind of frameworks, and they've been developing models within the industry, and then they've been using those frameworks to audit and the risk of those models and many different test cases that they've been using. So actually, we have those kind of like background information and already been highly respected frameworks that we use. So I think those are could be repurposed or maybe like modified to use within the safety the audits. But that would be my comment.
That's great. Let's do one more question since we're already low on time. I'm actually going to take it from Slido. I'm so sorry that we don't have more time. Okay, so the question here is, because this one got a lot of upvotes, what potential benefits exist from developing AI systems with greater than level 3 risk? Why build them at all? I'm going to put that to Roger.
What benefit do you get from those levels of AI? I think so if you have a system with a lot of autonomous capabilities, I think there are purely economic applications of that. People to automate fairly significant chunks of the economy. Whether that's a good thing or a bad thing is to be determined. But if you have AIs that could actually exceed human capabilities across the board, and there are a lot of beneficial things that we would like to do and humans maybe haven't figured out yet. The scientific and medical applications. And so I think there is just generally a lot of potential for what you get from AI systems that have these higher levels of capability. So I think we don't want to abandon that possibility. We want to proceed carefully and carefully measure the capabilities and rule out catastrophic scenarios along the way. But hopefully we can do that and then reap the benefits of the future AIs.
Are there any final words from our panelists on these last couple of questions? Sheila, I know it's on the spot, but if you have any other comments to add before we start to wrap up.
Good spot.
It's
okay. Maybe what I would say is that I think, AI used to be just the purview of computer scientists, and we worked away on these problems as philosophers, and we reflected on these problems in different ways. And I think that AI is now, we no longer own AI. AI is something for all of us. It's something that we all contemplate. It's going to affect us all in different ways. But I think it will be the case that in the future, we will have AI systems that are just going to be better than us at certain things. Better, faster, more consistent, more patient, working 24/7. And I think we as a society really need to think about how we want the world to be, how we want to integrate these new capabilities into our society, so that, back maybe to where I started, so that we can build a society where people have purposeful work and where they feel really valued. And I think it's something that we should all be reflecting on and working towards. And it's not just for the computer scientists or the big tech companies to figure this out. It's something that we can all really do it.
I'm going to rely on you for a wonderful comment to end us on, so thank you, Sheila. I'm going to say a few, and thank you to all panelists, but I will say a final thank you in just a second. So that is all the time we have for today. I'm so sorry. I always try to leave more room for questions, and I feel like I never have enough time for questions. I'm learning as we do more of these events, and there will be another event. We're going to have another September Soiree on Technophilosophy next year, just around the same time. So keep your eyes out for that too. So I want to thank our panelists once again for their time and generosity tonight. I also want to thank the Schwartz Reisman Institute for helping me put together tonight's event. Probably most importantly is Olivia Giuseppe, who's probably hiding in the corner there. Thank you so much. SRI has just announced their fall lineup for their SRI seminar series, which is open to absolutely everybody to attend. It's often done in a hybrid way on Zoom and in person. And in fact, one of the speakers for this fall will be Roger Grosse. So I encourage you to go to the Schwartz Reisman website to check out the fall seminar series. And of course, in addition to SRI, I want to thank again our partners for this event. That's the Vector Institute, U of T Center for Ethics, the Institute for the History and Philosophy of Science and Technology, and Victoria College. So finally, thanks to all of you for joining us tonight, for bringing your thoughtful questions, which I encourage everyone, including the speakers, to look at on Slido, because there are many great questions there. And finally, for your curiosity, your willingness to come out for an evening to think about these important topics of the moment. So thank you and have a great night.